a few more participants to join us. If you are having trouble hearing me, use the raise hand icon or type a help message in the chat box. Okay? Clear. Okay. Okay, it is 10:50 a.m. in Kuala Lumpur and the weather outside is cloudy. Ladies and gentlemen, may I have your attention? The webinar session is now begin. First and foremost, Assalamualaikum warahmatullahi wabarakatuh. Good morning, aloha, and bonjour. I am Ammar Ihsan, and here with me today is Dr. Shuhada, who will be your moderator. We would like to welcome the Honorable Professor Dr. Muhammad Hasni bin Muhammad Jaafar, our advisor and our module coordinator, distinguished guests from Ministry of Health, speakers, ladies and gentlemen, to this webinar session. In this special occasion, we will be delivering a webinar titled Toxicology Update on Common Heavy Metals in Malaysia. As we all know, heavy metals pollution has been an issue in Malaysia for many years. Among the contributory factors are the increasing population, rapid urbanization, continuous oil and gas production, heavy rainfall throughout the years, and various economic activities. The accumulation of heavy metals in the environment will eventually expose us to harmful health effects. Therefore, the main objectives of this webinar are: one, to present the latest update and recommendation on the toxicokinetics of four main heavy metals of cadmium, lead, arsenic, and mercury. And the second one is to educate Malaysians or people regarding the harmful effect posed by these heavy metals. Okay, without further ado, and as of the webinar tentative, I am going to invite Professor Dr. Muhammad Hasni bin Muhammad Jaafar, our advisor and our module coordinator, to deliver an opening remark. Professor, the floor is yours.
Assalamualaikum and good morning. Thank you, Mr. Chairman, Dr. Ihsan. Alhamdulillah, in the name of God, the merciful and the compassionate. Peace be upon him, Nabi Muhammad SAW, and all his family and companion, distinguished scholars, honors, ladies and gentlemen. It's my pleasure to express my deep appreciation to the webinar working committee for this excellent session. My thanks to the head department of the community health, UKM, and all involved directly and indirectly in this webinar for their great efforts in making the successful of this webinar. For everybody information, this is an annual activity for the toxicology module in the DRPH program UKM. Besides, they search and learn about the latest information about four most common heavy metals in Malaysia. I hope this webinar will also update all the audience on the same issue. Toxicology in Malaysia is not new, but still in the infant stage. Not many of the clinicians and public health physicians aware about the importance of it. And it is a real threat to the country and need more specialists to ensure the health of nation. I don't intend to take so much time this morning. So let's we hear from the update from our presenter. Assalamualaikum and jazakallah khairan.
Thank you very much, Prof, for the words. Now, before we start, let me explain the flow of our webinar. We will have a total of 4 presentations today. Each presentation is limited to 20 minutes only. To ensure the flow of the event, we will let all the presenters to deliver their speech uninterrupted. We will also mute the participants' microphones during this period. Therefore, the question and answer session will be at the end of our webinar. However, feel free to ask questions during the presentation by using the chat box that is available down below. And Dr. Shuhada, who is with me, will gather all the burning questions from the floors and will definitely answer them all during the Q&A session. Okay? Now, we will start our first presentation today with title Update on Lead. Before the presentation begins, I would like to introduce a bit of background of the first presenter. This first presenter is Dr. Arif Asfarahim bin Ibrahim. He is a 33-year-old married. His background is very impressive. Completed secondary school in a well-known institution, Malay College Kuala Kangsar, and further his medical study in Russia. He worked in Miri, Sarawak before and has vast experience there, and has also been in a flying doctor service. He is active in humanitarian work like volunteer during the flood disaster in Kelantan 2014, and also currently a passionate member of Ikram Health Group. So, all right, without any further ado, I would like to welcome the presenter, Dr. Arif. Dr. Arif, the floor is yours.
Assalamualaikum warahmatullahi wabarakatuh, and a very good day to everyone. Thank you for joining us on Toxicological Update today. So my name Dr. Arif Asfarah Ibrahim. Today I'm on behalf of my group, Dr. Maisarah, Dr. Nur Ayuni, Dr. Zulkifli. I will be presenting a topic entitled lead, which is one of the most common heavy metal in Malaysia. And this is the outline of my presentation for today. I will start with report on lead poisoning cases in Malaysia and USA, then followed by a bit of introduction, toxicological properties, and lastly a case for further understanding. So let's start. This was a study published in the year 2000, blood lead level of urban and rural Malaysian primary school children from Kuala Lumpur, Kemaman, and Sitiu. So from this study, it showed respirable lead and blood lead were highest in the Kuala Lumpur, and it was statistically significant. And from this study, we note that those Kuala Lumpur school children have 25 times greater risk of having excessive blood lead level compared to Kemaman and Sitiu school children as semi-urban and rural areas. And this was news in April last year. Over 6,000 Kampung Jenjarum folks at risk of lead poisoning. So this problem came from a factory that had been operating there for the past 5 years. So from the lab test on 12 hair samples of residents and workers, they confirmed high level of contamination. So it was very high. For the workers, the blood lead, the level of lead is 3,000 plus in hair sample. For the resident hair sample, the reading was 29.7 milligram per kilogram. Okay, so very high. And this was a study commissioned by International Persistent Organic Pollutant Elimination Network and carried out in Malaysia by Consumer Association of Penang. Analyzed on 10 playground, 9 in Penang and 1 in Kedah, with painted play equipment physical details and the condition of painted surfaces being observed and documented. So data was released during International Lead Poisoning Prevention Week last year, 2019 in October. It was recorded the highest rating in playground in Georgetown with lead level of 620,000 parts per million ppm found in yellow metallic handle structure. So this is almost 7,000 times greater than recommended limit of 90 ppm issued by UN Environment Program. So from all this report, I just want us to realize how lead can significantly affect our health, adults' health, but also in children when they're in playground, poisoning while working, and indirectly affect people surrounding. Thus, I hope my subsequent presentation will be really helpful to the audience. Okay. As introduction, the Institute for Health Monitoring and Evaluation estimated that in 2016, lead exposure accounted for 63.2% of the global burden of idiopathic developmental intellectual disability, 10.3% of the global burden of hypertensive heart disease, 5.6% of the global burden of ischemic heart disease, and 6.2% of the global burden of strokes. Lead exposure also accounts for about 0.2% of all death and 0.6% of disability adjusted life years globally. So also depending on the region, lead was ranked between 17th to 30th most important contributor to daily. Okay. So this data on global burden should raise on our awareness on preventing our population from lead toxicity. Okay. So lead is a naturally occurring element with an abundance of 0.0016% in the Earth's crust. It is a member of group 14 of the periodic table. It has an atomic number of 82 and atomic weight of 207.2. Basically, lead is a highly toxic metal, which is naturally occurring bluish gray metal found in small amount of the earth crust at about 15 to 20 milligram per kilogram. It has characteristic of very soft, highly malleable, ductile, and relatively poor conductor of electricity. CDC guidelines, blood lead level more than 5 microgram per deciliter considered high for adults. And for children, there were no value of blood lead is considered safe from harmful effect of the lead. So lead was widely used because it has such properties such as corrosion resistance, density, and low melting point, make it a familiar metal in pipes, solder, weight, and storage batteries. Next, lead does not degrade in the environment, although it can exist in various chemical forms. It's transferred continuously between air, water, and soil by natural chemical and physical process, such as weathering, runoff precipitation, dry deposition of dust, and river flow. So for adults, exposure to lead is usually associated with occasional exposure in working areas. For children, exposure to high level of lead is associated with living in areas contaminated by lead. For example, in early part, I shared the case in playground that contain of high level of lead in paint. So as shown in this slide, sorry. So lead could be produced by human activities such as industrial, mining, and agricultural activities that can spread by air, water, and soil. Okay, move on. This is a psychochemical property of lead. So lead with atomic number of 82, atomic weight of 207.2, and a specific gravity of 11.34 gram per centimeter cubic. It is a bluish or silver gray metal with melting point of 327.4 degrees Celsius and a boiling point at atmosphere pressure of 1,740 degrees Celsius. And it is also odorless. Okay, for the most studies endpoint, such as neurological, cardiovascular, hematological effect occur even at the lowest blood lead level, which is less than 5 microgram per deciliter. So because of the lowest blood lead level associated with serious adverse effects, thus minimal risk level for lead have not been derived. Okay. Next, no observed adverse effect level or NOEL. NOEL means the highest exposure level at which no harmful effect was seen in the organ system study. So NOEL for lead, we use erythrocyte protoporphyrin or EP. Why we use EP? Because lead cause accumulation of EP. So we can use it as a biomarker. So how it accumulates? Because lead inhibits heme synthesis. Okay, so by inhibition of heme synthesis, it also inhibit ferrochelatase enzyme. So when ferrochelatase enzyme inhibited, so the level of EP will increase. So they found out NOEL in EP level in infant and children exists at about 15 to 17 microgram per deciliter. For adults, EP level range from 25 to 30 microgram per deciliter. And female, the NOEL range from 20 to 25 microgram per deciliter, which is closer to the observed for children. Okay. And then how about LOEL? Okay, LOEL is a lowest observed adverse effect level. Okay, means the lowest exposure level of chemical in study or group of study that produce statistically or biologically significant increase in frequency or severity of adverse effect between the exposed population and control. So this is the loyal table for adult. We can see at certain value of blood level, it may cause adverse effect to a certain system of the body. For example, ALAT inhibition, which is enzyme in blood production, may affect at lowest as less than 10 microgram per deciliter. Okay. So this loyal table for children, same like adult, difference value had different health effect. Of course, the most severe effect had the higher value of blood level. Okay. Now we go through on toxicokinetic of lead, which comprise of absorption, distribution, metabolism, and excretion. Okay. Let's start with absorption. Okay, there were 4 routes of absorption of lead. First, most common route of absorption is in gastrointestinal tract. Okay. The fraction of ingested plumbum ingested lead absorbed from gastrointestinal tract depends on many factors, including age, diet, nutrition. Okay. But then children can absorb 40 to 50% of oral dose of water-soluble lead compared to adults, only 3 to 10%. Okay. And inorganic lead occurs, absorption occurs primarily in duodenum. Secondly, respiratory tract. Inhalation is the second major pathway of exposure for the general population. Okay. Lead in small size particle can be almost completely absorbed through respiratory tract, but then larger particle will be moved by mucociliary clearance toward the oral pharynx and swallow. Okay. And thirdly, dermal. Okay, of course, this route is much less efficient than the former two. Okay, dermal exposure usually occur among workers. Dust and soil content lead can get into the skin by pass through of the skin break and then enter bloodstream or ingested when not washed properly. Okay. And the fourth one, endogenous exposure. Okay. Lead poisoning may result from retained bullet or sharp fragment that caused by trauma, and also transplacental exposure to the unborn child that can happen if the mother is exposed to the lead. Okay. Okay. The distribution of lead in adult approximately 94% of the total body burden of lead is in the bone, compared to children only 73%. Okay. And lead accumulation predominantly occur in trabecular bone during childhood, and in both cortical and trabecular bone in adulthood. So the half-life of lead in bone is several decades. Some studies say 1 to 2 decades. Okay? And lead in blood primarily in red blood cell, almost 99%. The excretory half-life of lead in blood in adult human approximately 30 days. Lead also distribute to soft tissue. Relative amount of lead in soft tissue, liver about 33%, then skeletal muscle 80%, but then the highest soft tissue concentration in adult occur in liver and kidney cortex. So in terms of biotransmission of lead, okay, what is biotransmission? It's a biochemical function of human tissue or organ that produce alteration of chemical structure of lead by specific unlimited enzyme. Okay. So for organic lead, compounds are actively metabolized in the liver, okay, by we call it oxidative dealkylation by the cytochrome P450 enzyme. Okay. So for example, tetraethyl lead is metabolized to triethyl lead by oxidative dealkylation. Then last, excretion of lead. Okay, so lead is excreted primarily in urine and feces. Okay, regardless of the route of exposure. Minor route of excretion include sweat, saliva, hair, nails, breast milk, and also seminal fluid. But then fecal excretion account for 1/3 of total excretion of absorbed lead. Okay, then the elimination half-time in blood varies with age and exposure history and range from 1 week to 2 years. And elimination of lead from bones, half-time is 1 to 2 decades. Okay. And so next, what about bioaccumulation and biomagnification of lead? Okay. So what is bioaccumulation? Bioaccumulation is the process by which toxin enter the food web by building up in individual organism. So yes, indeed, lead is known to bioaccumulate in the organism, particularly in animal and plant which having lead in their environment. Okay. So, but then how about biomagnification? Biomagnification is the process by which toxins are passed from one trophic level to the next to increase in concentration within a food web. Okay. So basically, biomagnification of inorganic lead is not apparent. Okay. This is explained by the fact that vertebrate lead is mainly stored in bone, okay, which reduce the risk of lead transmission to other organisms in the food chain, because usually a predator will not eat the bone. However, I found out there was a study published in 2011 showed there was a biomagnification, but only in invertebrate predators and in special condition, which in this study were in their lab and field experiment. Okay. So after all, these are the signs and symptoms of lead poisoning. If you look at this picture, it almost affects all our organs in the body from head to toe. Okay. It affects vision, organ system, blood production. Okay. So those with lead poisoning will have sign of fatigue, lethargy, and those with severe blood lead level will have encephalopathy and etc. So the higher blood lead level in our body, the more severe it affects our health, both to adult and children. Okay? With blood lead level of 10, adult have hypertension, and for children, it affects the IQ level. Of course, with increase of blood lead level, the more severe health effect affected. Okay? And lastly, I would like to end my presentation with a case report of adult lead toxicity following use of Ayurvedic herbal medication. Okay, it is a traditional medicine with India origin. It's about 69 years old Caucasian male with prior history of stroke. He presented to hospital for evaluation of new onset depression, fatigue, generalized weakness, constipation, anorexia, and weight loss. Okay? So all those signs of lead toxicity. Right? History revealed that his symptoms were temporarily related to initiation of Ayurvedic herbal medication. Okay. The patient had been previously admitted to another hospital for the symptom and was found to have anemia 6.4, and no etiology was found. But then laboratory tests revealed an elevated blood lead level 94, almost 100, which can cause encephalopathy. So due to that, diagnosis of symptomatic lead toxicity was made. And the patient was treated with intramuscular, intravenous, and oral chelation therapy to promote lead excretion. Dimercaprol and calcium disodium EDTA were given. Because of complaint of continual poor mental function, neuropsychological tests were administered before and after one of the chelation treatment. And they will show improvement in the measure of attention and other cognitive domain. So he was discharged from the hospital at day 6. On that time, his blood lead level was 25.5. Okay, it's still high, but lower compared to during admission level. Okay, so found out it was caused by Ayurvedic plasma medication, which found to contain 90,000 plus milligram per kilo of lead, and also including arsenic. Okay, so this is our reference for this presentation. I think that's all. With that, thank you for your attention to this presentation. Thank you.
Thank you very much, Dr. Arif, for the presentation. Next, we will go on with the second presentation for today, titled Update on Cadmium. Before the presentation begins, I would like to introduce a bit of a background of the presenter. Dr. Muhammad Hilmi bin Mahmud is 34 years old, married and with 4 children. His background is also remarkable. He is an alumni of College Islam Sultan Alam Shah Kisas and subsequently completed his medical degree in Malacca Medical College. He has vast experience in hospital care, primary care, and public health field. He is also an active life member of Malaysian Society of Environmental Epidemiology, MICE organization, with great collaboration with Taiwan Healthcare. So without further ado, I would like to welcome the presenter, Dr. Hilmi. The floor is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Hilmi bin Mahmud. We're presenting toxicology updates on cadmium. My group members include Fadlisha and Muhammad Ammar Ihsan bin Ahmad Zamzuri. This is my content for today. I will talk about introduction, exposure, toxicokinetics and toxic dose, health effect, and lastly, treatment. So what is cadmium? Cadmium is a metal found in the Earth's crust associated with zinc, lead, and copper. Pure cadmium is a soft silver white metal, while cadmium chloride and cadmium sulfate are soluble in water. Cadmium has 8 stable isotopes, which 112 and 114 is the common isotopes. Usage of cadmium is can be found in batteries, about 83%. Cadmium also can be used in pigments, coatings, and platings, stabilizers for plastics, non-ferrous alloys, photovoltaic devices, and other uses. So what is the sources of cadmium in the environment? Cadmium occurs in the Earth's crust in abundance, associated with zinc, lead, and copper ores. Cadmium also a natural constituent of ocean water, with higher level reported near coastal areas and in marine phosphate and phosphorites. Natural emission of cadmium resulted from volcanic eruption, forest fires, generation of sea salt aerosols, or other natural phenomena. So what is the fate of cadmium in the environment? In the air, cadmium will exist as particles or vapors. It can be transported long distances in the atmosphere where it will deposit onto soils and water surfaces. While in the soil, cadmium and its compound may travel through soil, but its mobility depends on several factors such as pH and amount of organic matter. Generally, cadmium binds strongly to organic matter where it will be immobile in soil and be taken up by plant life, eventually entering the food supply. In the water, cadmium exists as hydrated ion or ionic complexes with other inorganic or organic substances. Soluble forms migrate in water, while insoluble forms of cadmium are immobile. and will be deposited and absorbed through sediment. How might I be exposed to cadmium? Food and smoking is the primary source of exposure. Primary source of exposure is from food supply in generally leafy vegetables, potatoes, grains, peanuts, soybeans, and sunflower seeds contain high levels of cadmium, approximately 0.05 to 0.12 milligram cadmium per kilogram. Tobacco leaves accumulate high levels of cadmium from the soil. The national geometric mean blood cadmium level for adults is 0.38 microgram per liter. While in a study involving New York City smokers, they found out that geometric mean blood cadmium level are 1.58 microgram per liter, which are equal to smoking 1 pack of cigarette per day, about 1 to 3 microgram per day. In the air, only involve those who living near cadmium emitting industries. In the water, elevated cadmium level in water sources in vicinity of cadmium emitting industries has been reported. Aquatic organism will accumulate cadmium and again possibly entering the food supply. Occupational exposure is a highest risk of exposure from process involving heating cadmium containing materials such as melting and electroplating. Major role of exposure is through inhalation of dust and fumes or incidental ingestion from contaminated hands, food, or cigarettes. So how cadmium enter and leave human body? Primarily, cadmium enter human body via food and smoking. About 5 to 50% of the cadmium will enter body through lungs. Ingestion, only a small amount of cadmium in food and water will enter a body through digestive tract. Thermal contact, virtually no cadmium enters our body through our skin. For exit, most of the cadmium that enters body go through kidney and liver, which remain there for many years. A small portion of cadmium enters body slowly, leave via urine and feces. Our human body can change most cadmium to a form that is not harmful, but too much cadmium can overload the ability of liver and kidney to change the cadmium to a harmless form. We're going to toxicokinetics. For absorption, cadmium metal and cadmium salts are not well absorbed. Only less than 1% of the dose is absorbed following inhalation, oral or dermal exposure. Cadmium is not known to undergo any direct metabolic conversion such as oxidation, reduction or alkylation. Absorbed cadmium excreted very slowly, with urinary and fecal excretion being approximately equal. For absorption via inhalational route, some deposited in the airways or lung and the rest will exhale. Determinant of absorption depends on particle size. Larger particle size, more than 10 micrometer diameter, will be deposited in the upper airways, while smaller particle around 0.1 micrometer in diameter will enter alveoli and get absorbed. While oral route absorption estimated range from 1.1 to 10.6%. Some portion may be trapped in the intestinal mucosa without crossing into the blood or lymph. Physiology status factor also may increase absorption of cadmium, such as older age, lower body stores of iron, low calcium and lower zinc, and also pregnancy. In a study that shows low iron stores in the body will make average absorption of cadmium about 6 to 8.9%. While if there is adequate iron stores in the body, average absorption of cadmium is around 2.3 and 2.4%. In dermal route, most of the cadmium, around 74 to 93%, remain unabsorbed and was recovered from the skin surface. For distribution, cadmium is widely distributed in the body, with major portion of the body burden located in the liver and kidney, again dependent on duration of exposure. Inhalation route distribution, in the human study, greatest concentration found in the liver, kidney, pancreas, and vertebrae. In the liver, occupational exposed worker, cadmium concentration generally increases in proportion to intensity and duration of exposure to values up to 100 microgram per gram. In the kidney, cadmium concentration rises more slowly than in the liver after exposure and begins to decline after the onset of renal damage at a critical concentration of 160 to 285 microgram per gram. Distribution via oral route, cadmium can be detected virtually in all tissues in adults from industrial countries, with greatest concentration again in liver and kidney. Placenta may act as a partial barrier to fetal exposure to cadmium. In a study, they found cadmium concentration approximately half as high in cord blood as in maternal blood in several studies, include both smoking and non-smoking women. While dermal route distribution, there is no study in human. For metabolism, cadmium is not known to undergo any direct metabolic conversion. The cadmium ion does bind to an ionic group, especially sulfhydryl groups in proteins, especially albumin and metallothionein and other molecules. Plasma cadmium circulates primarily bound to metallothionein and albumin. For elimination and excretion, most cadmium that is ingested or inhaled transported to the gut via mucociliary clearance is not absorbed and is excreted in the feces. Absorbed cadmium is excreted very slowly, with urinary and fecal excretion being approximately equal. Half-time for cadmium in the whole body was more than 26 years. Inhalational route, elimination and excretion. Cadmium excretion in urine increased proportionally with body burden of cadmium. Excreted cadmium represent only a small fraction of the total body burden unless renal damage is present. For fecal excretion in workers occupationally exposed to cadmium reflects mainly cadmium dust swallowed from industrial air and or incidental ingested from contaminated hands. While oral route, major proportion of administered cadmium is found in the feces because absorption is so low. Fecal excretion constitute unabsorbed cadmium plus through excretion originating from blood via the intestinal wall. Urinary excretion depends on blood concentration and kidney concentration, and a total excretion is assumed to equal daily intake at steady state. For dermal route, elimination and excretion, there is no human study found. We go to minimal risk level for cadmium. For inhalation exposure of cadmium, for acute inhalation exposure, an MRL of minimal risk level 0.03 microgram cadmium per meter cube has been derived for acute duration inhalation exposure less than 14 days to cadmium. For chronic inhalation exposure, MRL of 0.01 microgram cadmium per meter cube has been derived for chronic duration inhalation exposure 1 year and above to cadmium. In oral exposure of cadmium, intermediate exposure and MRL of 0.5 microgram cadmium per kilogram per day has been derived for intermediate duration oral exposure, 15 to 364 days to cadmium. While chronic, which is 1 year and above, MRL of 0.1 microgram per kilogram per day has been derived. We move to toxic dose. For inhalation, ACGI has recommended threshold limit value for air exposure to cadmium dust and fumes is 0.01 for total dust to 0.002 for respirable dust milligram per meter cube as an 8-hour time weighted average. Exposure to 5 milligram per meter cube inhaled for 8 hours may be lethal. The level considered immediately dangerous to life or health for cadmium dust or fume is 9 milligram per meter cube. For ingestion, cadmium salts in solution at concentration more than 15 milligram per liter may induce vomiting. The lethal oral dose ranges upward from 150 milligram. For water, U.S. Environmental Protection Agency established a safe limit of 0.005 milligram per liter in drinking water. So what is the mechanism of toxicity of cadmium? Cadmium is toxic to a wide range of organs and tissue. The primary target organ for cadmium are kidneys, bone, and lung. Changes in kidney we can find chronic exposure to cadmium by the oral or inhalation route has produced proximal tubular cell damage, proteinuria, glycosuria, amino aciduria, polyuria, decreased absorption of phosphate, and enzymuria in humans. Depletion of antioxidant enzyme such as glutathione peroxidase and superoxide dismutase has been proposed as the mechanism of cadmium cardiotoxic effects. Cadmium has been shown to alter zinc, iron, and copper metabolism as well as selenium. Initiating step in cadmium-induced toxicity to the testis is cadmium interference with zinc protein complexes that control DNA transcription, which subsequently leads to apoptosis. Cadmium sequestration by metallothionein or chelator prevents cadmium from disrupting zinc-dependent transcriptional controls. So this figure shows main target in cadmium intoxication in mitochondria. So cadmium acts on mitochondria by inducing oxidative stress and generating reactive oxygen species, ROS. Cadmium also activating apoptosis, mutating mitochondrial DNA, altering gene expression, inhibit respiratory chain complexes, reducing ATP synthesis, and altering inner mitochondrial permeability. Here is the health effect of cadmium exposure. We can see via inhalation group, the health effect is more prominent. Can be death, systemic, immunologic, neurologic, reproductive, developmental, genotoxic, and cancer. While dermal only give rise to acute and also immunologic health effect. So clinical presentation for direct contact can cause local skin or eye irritation. Acute inhalation cause cough, dyspnea, headache, fever. If severe chemical pneumonitis and non-cardiogenic pulmonary edema will happen within 12 to 36 hours after exposure. For chronic inhalation, it results in bronchitis, emphysema, and fibrosis. Chronic inhalation at high level is associated with lung cancer. For acute ingestion of cadmium salts, it can cause nausea, vomiting, abdominal cramps, and diarrhea, sometimes bloody, within minutes after exposure. Deaths after oral ingestion result from shock or acute renal failure. For chronic ingestion associated with kidney damage and skeletal system effects, it can be seen in environmental contamination of food and water in Japan's Jinzu River Basin in 1950s, resulted in endemic painful disease called itai-itai. How to diagnose cadmium intoxication? Based on history of exposure and the presence of respiratory complaint or gastroenteritis. For specific level, we can take whole blood cadmium levels to confirm recent exposure. Normal level in unexposed non-smoker are less than 1 microgram per liter. While for urine cadmium, values are normally less than 1 microgram per gram of creatinine. Very little cadmium is excreted in the urine until binding of cadmium in the kidney is exceeded or renal damage occurs. Other useful laboratory studies that can be done include complete blood count, electrolytes, glucose, blood urea, creatinine, arterial blood gases or oximetry, and chest radiography. For treatment, for emergency and supportive measure in inhalation route, we have to monitor arterial blood gases and obtain chest radiograph. Observe for at least 6 to 8 hours and treat wheezing and pulmonary edema if they occur. After significant exposure, it may be necessary to observe for 1 to 2 days for delayed onset non-cardiogenic pulmonary edema. For ingestion, treat fluid loss caused by gastroenteritis with IV crystalloid fluids. Specific drugs and antidotes, there is no evidence that chelation therapy is effective, although various chelating agents have been used following acute overexposure. BAL, penicillamine, and EDTA are contraindicated owing to increased risk of renal damage. For decontamination, first inhalation, we have to remove the victim from exposure and give supplemental oxygen if available. Ingestion we have to perform gastric lavage after significant ingestion. However, the effectiveness of activated charcoal is unknown. For skin, we have to remove contaminated clothing and wash exposed skin with water. Irrigate exposed eyes with copious amounts of tepid water or saline. So how can families reduce the risk of exposure to cadmium? First, do not smoke tobacco products. Cadmium accumulates in tobacco leaf. This study shows that mean blood cadmium level for heavy smokers as high as 1.58 microgram per liter. Second, good occupational hygiene. Occupational exposure can be controlled through personal protective equipment, good industrial hygiene practices, and control and reduction of cadmium emission. Children also can be exposed to cadmium through parents. Therefore, good hygiene practices such as bathing and changing clothes before returning home may help reduce the cadmium transported from the job to the home. Number 3, avoid cadmium contaminated areas and food. Check and obey local fishing advisories before consuming fish or shellfish from local waterways. Avoid hazardous waste sites. Number 4, proper disposal of cadmium containing products. Dispose of nickel cadmium batteries properly. Many states have laws in effect that ban the disposal of battery as municipal waste. Recycle all batteries whenever possible. Contact your local waste and recycling authority on how to properly dispose of paints and coatings. Lastly, do not allow children to play with batteries. If mishandled, batteries could rupture. So there is a case that where children also swallow small nickel cadmium batteries. This is our list of references. With that, thank you.
Thank you very much to Dr. Hilmi for the presentation. Before we proceed with the next presentation, these are some housekeeping announcements. Please register your name in the Google form so that you all will be eligible to get e-certificate. We have already shared the link for the Google form in the chat box. Number 2, don't forget to drop down your burning question at the chat box below. And number 3, for those who have not scanned QR codes, you can do it so at the end of the webinar session. Okay, so our next presentation titled Update on Arsenic. So Dr. Kavita Jetli, anak perempuan Jagajit Kumar Jetli, is our next presenter. She has a stunning background since completion of medical degree from AIMS University. She has contributed a lot in the research areas during her tenure at Clinical Research Center, Ipoh Perak. All right, without any further ado, I would like to welcome the presenter, Dr. Kavita. The floor is yours.
A very good morning to our respectable audience. I'm Dr. Kavita, and I'll be representing my group comprising of Dr. Ihsan and Dr. Nursuhada on the toxicology updates on the common heavy metals in Malaysia. I'll be presenting on arsenic. This is the outline of my presentation. A bit on introduction, sources of arsenic exposure, epidemiology, health effects, arsenic removal, and conclusion. So, arsenic got its name from Greek word arsenikos, means male or yellow ornament. Arsenic is a metalloid, that means it has properties between metals and non-metals. Arsenic prefers to bond with a lot of elements, including oxygen and hydrogen. In the environment, arsenic can occur in multiple oxidation states. In natural water, arsenic is mainly found as arsenite and arsenate. Okay, this slide shows the various forms of arsenic metals, such as realgar, orpiment, arsenolite, arsenopyrite, and so on. There are two forms of arsenic compounds, which are inorganic compounds and organic compounds. Inorganic compounds of arsenic are mainly found in the industry, in building products, and also in arsenic-contaminated water. These inorganic compounds tend to be more toxic form of arsenic and has been linked to cancer. They are carcinogenic, IARC Class 1 and US EPA Group A. Organic compounds are formed in foods such as shellfish and fish. These organic compounds tend to be less toxic and not thought to be linked to cancer. There are various sources of arsenic toxicity. Sources of arsenic exposure include drinking water. Drinking water is the leading cause of arsenic exposure. This includes contaminated groundwater, which is a major source of drinking exposure. Drinking water is basically contaminated by arsenic by various natural sources, such as erosion and leaching from geological formations, such as arsenic from arsenic-rich rocks and minerals, and also other anthropogenic sources, such as industrial processes. Arsenic are also found in food, usually crops which are irrigated with contaminated water, and food which is prepared with contaminated water can be a source of exposure of arsenic. Other food which has arsenic includes fish, shellfish, meat, poultry, dairy products, and cereals. Arsenic are also found in seafood. Arsenic are also found in various industrial processes. This includes mining activities, metal processing, pesticides, and fertilizers. Arsenic are also found in tobacco. This is because the tobacco plants can take up the naturally occurring arsenic which is present in the soil. Arsenic are also found in cosmetics and also found in the air. In the air, arsenic is predominantly attached to particulate matter. Arsenic is usually present as a mixture of arsenite and arsenate, with a negligible amount of organic arsenic. This slide shows the various sources of arsenic. So, arsenic can be emitted and produced from anthropogenic sources as well as natural sources. From anthropogenic sources, this includes industrial emission and runoff, pesticides and fertilizers. From natural sources of arsenic includes vulcanization, forest fires and rock weathering. Therefore, this arsenic from the anthropogenic and natural sources will be leached into the ground as arsenic compounds and sediments, and they will contaminate groundwater. This contaminated groundwater can be taken up by plants and contaminate other food. Hence, humans will be exposed to arsenic when they drink the contaminated food and water which has arsenic. Arsenic is found in many foods. This slide shows the level of arsenic in various foods, such as rice, meat, which is beef, cooked spinach, chicken, grape juice, shrimp, fish. Arsenic is also found in water. In water, 10 parts per billion is the maximum concentration allowed, which is equivalent to 0.01 milligram per liter or 100 micrograms per liter. Malaysia. The drinking water quality standard in Malaysia follows the WHO standard of drinking water quality. The recommended raw water quality and drinking water quality standards of arsenic is 0.01 milligram per liter. The following shows the various epidemiology of arsenic exposure. In worldwide and Asia, About 200 over million people are exposed to arsenic concentration in the drinking water, which exceed the recommended limit of 10 microgram per liter based on WHO guidelines. Majority of them live in Southern Asian countries, which includes Bangladesh, Cambodia, India, Nepal, and Vietnam. Besides that, elevated level of arsenic has been found in Latin America, Argentina, Bolivia, Chile, and Mexico. For the latest years, between 2000 and 2015, arsenic-contaminated groundwater has emerged in various Asian countries, including our neighbors Mongolia, Cambodia, Nepal, Afghanistan, Myanmar, Western Iran, Korea, Vietnam, and Pakistan. Besides that, India and Bangladesh are the worst affected among Asian countries in case of arsenic groundwater contamination. Proceed to Malaysia. In Malaysia, this graph shows the annual average concentration of arsenic in rivers across Malaysia from 2013 to 2018. As we can see, there is a gradual decline of the arsenic concentration in the rivers from the year of 2013 to 2018. The average concentration is said to be around 6 milligram per liter. A review was also done by this author, Yunus et al. From all the other published articles on the accumulation of heavy metal, including arsenic, in the coastal sediments in Peninsula and also in East Coast Malaysia. As we can see in Peninsula Malaysia, the highest level of arsenic is seen in 2013 in Port Klang, about 475.26 ppm, and this is followed by the Mangrove Peninsula in the study which was done in 2015, which shows a level of 41.43 ppm. In East Coast, the highest level of arsenic is seen in Kuantan River with a level of 42.30 ppm. Another review was done to show the level of arsenic specifically in drinking water in Langat River Basin in Malaysia. So the results shows that arsenic concentration along this time series data from 2004 to 2015 was significantly within the maximum limit of 0.01 milligram per liter of drinking water quality standard set by WHO. And long-term ingestion of arsenic via household filtration showed no potential lifetime cancer risk. And then now I'll proceed to the various health risks of arsenic ingestion. Just a recap on previous presentation. So therefore, as I said, organic arsenic is less harmful and is not linked to cancer. In contrast, inorganic arsenic is the one which is carcinogenic. So for acute exposure, what do we get when we are acutely exposed to arsenic? We can have symptoms like vomiting, abdominal pain, diarrhea. This is followed by various numbness and tingling of extremities, muscle cramping, and death in extreme cases. Chronic exposure of arsenic is linked to various skin lesions. As you can see in this picture, skin lesions. It is said to have developed skin lesions after a minimum exposure of 5 years, and these skin lesions are a precursor to skin cancer. Skin lesions include pigmentation changes, skin lesions, and hard patches on the palms and soles. Arsenic chronic exposure is also linked to various carcinogenic effects such as bladder cancer, skin cancer, lung cancer. Other effects of arsenic include developmental effects, diabetes, pulmonary disease, cardiovascular disease, and arsenic is also linked to various adverse pregnancy outcomes, and impairs child health. So this study was done regarding the assessing of potential mechanisms of arsenic-induced skin lesions and cancers. So arsenic causes skin lesions where various immunological dysfunction, and there are also various markers of hyperkeratosis and carcinogenesis which are caused by arsenic. This pictorial diagram basically shows the health effects of arsenic, which I have described in previous slides. Now we will go on to arsenic removal, since we know arsenic has been linked to many adverse health effects, and there are many sources of exposure of arsenic. Hence, it is very important for us to detect and remove arsenic. So, what is the most recent? We will go to the most recent arsenic detection technology. So, what happened is this smart researchers engineer, they have invented a plant-based sensor, and this plant-based sensor will monitor the arsenic levels in soils. So how this works is where these optical nanosensors are embedded in plants to non-destructively assess and monitor the internal dynamics of arsenic taken by plants via roots. So then they can detect the amount of arsenic which is present in the soil. For arsenic removal technology for eco solution, there are a variety of technologies which is available. This includes these chemicals require many stages of pre-treatment or chemical reduction of contamination. So the precipitation of trivalent iron salts and lime. So this is the most commonly applied technique in mining effluents. There are also other various technology for arsenic removal from mining effluents. I will just go briefly. This includes major oxidation or precipitation technology, air oxidation, chemical oxidation, major coagulation or co-precipitation technology, where they use alum, they use iron or lime treatment, and other technologies such as major ion exchange and major membrane technologies, which use technologies such as nanofiltration, reverse osmosis, and electrodialysis. So surprisingly, there are also arsenic removal technology using bacteria. This is also one of the most recent arsenic removal technology. So bacteria such as WS3, WS9, and WS11, they have shown different affinities and capacities to remove arsenic and arsenite from aqueous solution. So what happens is when we add an acid, the ability of this bacteria to remove arsenite and arsenic is increased after acid washing. Hence, as I have presented in the previous slide, arsenic is also present in rice and crops. So what we can do at home is there are a variety of cooking method. There's one particular cooking method which can maximize arsenic removal while preserving nutrient elements. So this is known as the parboil with absorption method. So what they do is you add fresh water and then you add the rice and you boil both of them together. And then what you do is you discard the water which has arsenic contamination in the rice, and then you change the water, you add fresh water, and then now you cook the rice. So this method has shown to be highly effective to remove inorganic arsenic from brown rice. About 54%, half of the arsenic can be removed, and in white rice about 73%. So, in conclusion, the exact magnitude of these estimates may be uncertain. Millions of individuals in South and Southeast Asia are at increased risk of arsenic-related diseases and mortality. Hence, future public health research should emphasize on arsenic mitigations in most severely affected areas. Additionally, various future molecular and genetic epidemiologic findings may have potential translational implications for prevention and treatment of arsenic-related toxicities worldwide. These are our references used in the following slides. With that, I thank you.
Thank you very much to Dr. Kavita for everyone's attention. Dr. Kavita is in her hometown in Penang, so we hope she's fine over there. Okay, so now we are going for our last presentation for today, titled Update on Mercury. This last presentation will be delivered by our dedicated and beloved Dr. Chua Su Peng, a first-year DRPH student. She has a remarkable background upon completion of her medical degree from Monash University. She is currently focusing her DRPH thesis on environmental field under the supervision of Prof. Dr. Muhammad Hasni. All right, without any further ado, I would like to welcome the presenter, Dr. Su Peng. The floor is yours.
Thank you, moderator, for the kind introduction. My name is Su Peng, and I will be presenting on Mercury update and case report. These are my fellow teammates, Dr. Muhammad Fikri and Dr. Muhammad Nazrin. This is the content outline of my presentation. Mercury is considered by WHO as one of the top 10 chemicals of major public health concern. Exposure to elemental mercury, even in small quantities, can cause serious health effects to fetus and children as it is a neurotoxin. Effects of mercury exposure depend on a number of factors. For example, the form of mercury, the amount of mercury exposed, the age of the person exposed. For example, unborn infants are the most vulnerable to mercury toxicity, how long the exposure lasts, how the person is exposed, is it via breathing, ingestion, or skin contact, and the health status of the person exposed. This table shows the physical and chemical properties of mercury. Mercury is found in 3 valence states, and its most stable form is elemental mercury. There are also 2 ionic forms of mercury, and inorganic mercury forms weakly soluble salts in water. This table shows the acute and chronic effects of exposure to mercury, targeting the cardiovascular, pulmonary, gastrointestinal tract, and central nervous systems. Other systems that are involved in mercury toxicity include hepatic, renal, and musculoskeletal systems. This table shows the acute and chronic effects as well as the cancer risk based on EPA classification of elemental mercury, inorganic mercury, and methyl mercury. Elemental mercury is classified under Group D, which is not human carcinogenic, whereas inorganic mercury and methyl mercury are classified under Group C, which is possible human carcinogenic. Moving on, I will now share with you a case study of a rare event of mercury exposure in Penang. The case definition is individuals exposed to mercury from 21st to 31st May 2016 in SPT and SPU District, Penang. On 26 May 2016, PKD SPT received a notification from Hospital A stating that 56 students were quarantined due to mercury exposure. A rapid assessment team and rapid response team were formed to investigate the incident. Three friends, IK, AZ, and ZK, discovered the silver liquid in an abandoned hut amidst a palm oil estate in SPU district and collected approximately 700 ml in a plastic bottle and brought it back home. They then distributed it into 3 parts and played with it with their bare hands. The picture on the left shows the abandoned hut where the silver liquid was found by the 3 friends, and the picture on the right shows the silver liquid lying scattered on the ground of the abandoned hut. IK then brought the silver liquid to school and distributed it to his friends. His science teacher realized that it was mercury and alerted the school authorities. The school authorities then reported it to the police department, JKKP, Fire and Rescue Department, Chemistry Department, ED of Hospital A, and PKD SPT. Hazardous Materials Squad Hazmat carried out the mercury spillage measures, and 5 houses were searched, 3 index houses and 2 neighboring houses. Active case detection was performed by PKD SPU and a police report was lodged. The investigations carried out included decontamination measures by Hazmat, which were carried out in the 5 houses, and mercury vapor analysis, which was carried out at the 3 index case houses. The results showed that 54% of the individuals exposed were female, while 81% of them had EPID link with IK. 78% of the exposed individuals were students. Almost approximately 41% of the individuals exposed to mercury developed cough, followed by shortness of breath and nausea. Others developed headaches, dizziness, and diarrhea. The environmental studies include mercury sampling, mercury vapor analysis, water sampling, and mercury ground search. This is the house of index case number 1, which was cordoned off during the incident. Physical inspection of mercury was carried out and no mercury was detected. The agencies also performed a walk-through survey using a mercury survey meter where point sampling was done with readings at 15 minutes interval. The first location that point sampling was carried out was in the living room, followed by the garage. This is the picture of the walk-through survey with point sampling at 15 minutes interval. Moving on to the house of index case number 2, where most mercury was found in this house. Traces of mercury were detected despite spillage measures by Hazmat. The plastic bottle containing mercury was also given to the PKD staff. This picture shows the traces of mercury which was found in the areas surrounding the house, and the plastic bottle which was found to collect the silver liquid is depicted on the right. This is the picture of the machine used for mercury vapor analysis in the garage. This is the picture of Hazmat team carrying out investigations at SMK-GP class number 1 and SMK-GP class number 2, where they found traces of mercury. This picture shows that the Hazmat team performing the environmental investigations and sampling. And this graph shows that the most mercury was found in the living room of house of index case number 2, which is approximately 11 microgram per meter cube. Water sampling was taken from 4 sampling points in the palm oil estate where the mercury was found. It was subsequently sent to chemistry department for analysis. The water sampling results came out negative as levels were detected less than 0.001 milligram per liter. The palm oil estate spanning 11.06 hectares was searched by Jabatan Alam Sekitar for mercury, and there were no mercury detected. For the laboratory investigations, 146 blood and urine samples, spot and 24 hours, were taken and tested for presence of mercury. 70 samples were taken from the index cases and their contacts in Hospital A. 76 samples were taken by PKD from the staff of various agencies involved in the incident. All the samples were sent to the laboratory in Hospital A and subsequently to Chemistry Department. For the blood specimen, AZ tested positive for mercury in his blood, whereas for urine specimen, there were 5 contacts who tested positive from AZ as well as ZK, and ZK himself tested positive for urine. Mercury in blood or urine specimen more than 0.001 microgram per liter is considered as positive. A total of 76 specimens of blood and urine samples were sent to Chemistry Department from staff from various agencies, and all of them returned as negative. After discussing with the specialists involved, no chelation therapy was commenced as the results were not that significant. Dimercaprol, which is a medication used for acute mercury toxicity, was borrowed from a hospital and subsequently returned. Plans to purchase Saximer, which is a chelation agent, were approved and sent to Penang General Hospital for safekeeping. For discussion, the source of heavy metal exposure was confirmed to be mercury. All the individuals exposed to mercury were tested and treated accordingly. Epidemiological, environmental, and laboratory investigations were carried out together with immediate control measures. The local community are now more alert and aware of the dangers of heavy metal exposure, especially mercury. This lorry shows the quality alarm lorry used for disposal of furniture. And this picture shows the briefing prior to decontamination works. This picture shows the hazmat team carrying out disposal works post-exposure to mercury at ZK's house, where they had to dispose of the mattress and the refrigerator. And this is other picture showing that disposal works post-exposure to mercury at ZK's house, and decontamination works being carried out after traces of mercury were found in the surroundings of the index case house. They had to use a pipette to draw out the mercury that was found on the ground. As a conclusion, once the source of exposure is confirmed, multi-agency cooperation is required to manage the exposure. Epidemiological, environmental, and laboratory investigation is equally important to contain the exposure. Occupational hazards to the staff of each agency is also critical and should be monitored. I would like to acknowledge Jabatan Kesihatan Negeri Pulau Pinang, PKD SPT, and PKD SPU for their help. This is the declaration, and we would like to declare that there is no conflict of interest while carrying out this study. And with that, I thank you for listening to this presentation.
Thank you very much to Dr. Suping for the insightful presentation. All right, ladies and gentlemen, now we come to the question and answer session. We have received several wonderful and brilliant questions from the audiences. Let me be honored to read the question and have the respective team answer it. We will follow the order of question with the order of presentation. So the group that presented just now will start. Okay. Thank you, Dr. Shuhada. Okay, so for the first question to the LED group. Okay, what group of, the first question from Dr. Sharul. Should we do lead screening among young children in Malaysia, since United States and some of Europe countries do early screening for lead? For example, in US, the child is screened once before 2 years old. So is there any limitation to implement such screening in our country? Okay.
Okay, thank you to moderator, Dr. Ihsan, and thank you for the Dr. Shahrul for the question. So should we do lead screening among young children in Malaysia? So I found out it's quite difficult to answer because I think for now we don't have concrete evidence to to uh, to give a idea to our policy holder to make such a decision. Okay, so scientific evidence that our children in Malaysia really need this kind of screening. Let's say if we found out there is need to do this kind of screening, and if we do such policy, are we ready to do next action for that, such as do we have enough resources? That's about the limitation lah. Okay, do we have enough resources like cost to do any lab test for the screening, and do we have expert to do treatment if we found out any toxicity? Okay, and many health effects on children, mostly we found out at chronic state, whereby the health effect usually affect the IQ, affect the development of children. So we need to have this run the screening. Okay, so if we have the screening but then we don't have any plan to overcome this situation, so I think it's not useless, but the objective to do the screening at early stage is to overcome this kind of health effect to the children. So I think that's my answer.
Okay, thank you very much, Dr. Arif. So we have also a second question for your group. The next question will be, what groups are most risk of getting lead poisoning? So what are the groups that are most risk at getting lead poisoning?
Okay, thank you. So I think this question from Dr. Fadli is much related to the first question. Okay, so of course the most risk because they are the vulnerable group in our community. And as I explained in my presentation, children are highly ingested lead through the gastrointestinal tract, 40 to 50% compared to adult. And children most of them at young age easily get the lead through the hand to mouth by exposure to the toys. Okay, and because paint at the toys still contain the lead that currently allowed not more than 90 ppm. So still there is risk for children by getting from the toys. Okay, so I would not say who exposed to lead exposure, they supposed to have good monitoring. Okay, and with that they will have good treatment as early as possible. Okay, so children again is the most risk group, and they have a chronic effect if we cannot detect at early stage. Okay. Okay, moderator, is there any more question?
Okay, thank you very much, Dr. Arif. It seems like we are actually running out of time. We have until 12:30. So there is one more question to you, but I will hang on to that. So we go to the cadmium group. Okay, I think. Okay, sure. All right, so to the cadmium group, there's two questions I'm going to articulate now. The first one is number one, is there any relationship of smoking with cadmium level in the body? That's the question number one. And number two, is there any occupational risk of cadmium exposure in Malaysia? I think the first question was from Dr. Intan and the second question was from Dr. Nazrin. So I hope the representative from cadmium group can answer it. Thank you.
Thank you, Mr. Moderator. Good morning, everyone. I'm Fadli. I'm the representative of second group. So for the first question, regarding any relationship of smoking towards the level of cadmium, actually a lot of study already shown that smoking behavior can increase the level of cadmium in the blood and also in the urine. And there is a study in Malaysia by our colleague in UPM in 2018. It shows that the blood cadmium will be high as high as 5 times among the smokers compared to the non-smokers. And for the second question, may I know what is the second question? Sorry,
Okay, sorry. Okay, the second question is there any occupational risk of cadmium exposure in Malaysia? The question from Dr. Nazrin. I think the question is to Dr. Hilmi.
Boleh dengar ke?
Loud and clear, Dr. Hilmi.
Okay,
please.
sorry. So second question, is there any occupational risk of cadmium exposure in Malaysia? There's two studies that I get for occupational exposure, where both studies shows no significant results. There's a study done by Rohi in 2012, done among farmers in Kedah, that shows that the level of heavy metal was within normal range. While another study by Sharifah in 2018, study done among municipal waste operators, that they have exposed to minimal cadmium, but it's not significant. Instead, in this study, they found that smoking and years of smoking were significant predictors of cadmium in the urine. So in Malaysia, for recent study, I only found this two among farmers and among municipal waste operators, which shows no significant results. Thank you.
Okay, thank you very much, Dr. Hilmi. So there's a question from the floor towards the Arsenic group. The first question from Dr. Maisara. Are you ready? The question from Dr. Maisara. So the question sounds, what are the advantages and disadvantages of chemical precipitation technique, which is commonly used in Malaysia? That's number one. And number two, from Dr. Arif, what is the safe level of arsenic in food? So those are the two questions. Please, the representative from Arsenic group. Thank you.
Thank you very much, Dr. Ihsan, and also for the questions. Firstly, I will answer the question of what are the advantages and disadvantages of chemical precipitation use. So as I said, it's a very common method used in Malaysia. So the advantages of this method is it's a very low cost and also a simple operation is easy to be done. And there are also disadvantages because using this method produce a lot of toxic sludge, and also there are a lot of steps such as oxidation and sedimentation and other steps which may produce harmful byproducts. Okay, I hope I answered this question. And for the next question, for the level of arsenic in food, so we were finding we only could actually find the level of arsenic in water. As I said, it's 10 parts per billion or 0.01 milligram per liter. So we did further research, and also finally we found that according to this EPA, Environmental Protection Agency, there is actually no safe level for this inorganic arsenic in food. As we know, as I've presented, in food, our arsenic is the inorganic form, which is not carcinogenic. So far, there is no safe arsenic level in food. In comparison to water, the arsenic is it's carcinogenic. I hope I answered those two questions.
Okay, thank you very much, Dr. Kavita. So there's a couple of questions to Mercury group. Maybe Dr. Chua Suping can get ready. So the first question is, with regards to the mercury exposure in school, were the remedial actions delayed from the first day of the event? And number two, the second one was given by Dr. Fadli. After the mercury exposure, were there any updates of those students after 4 years of the event? So those are the questions.
Okay, thank you for the questions, moderator. Firstly, for the first questions, I feel that the actions were not delayed because immediate remedial actions were taken once the notification was done. I would say that despite it being close to a weekend, the PKDs acted rapidly with the help of various agencies and the school authorities. I think with regards to the delay, it was in terms of seeking treatment, as parents and the students were not alert that the silver liquid was actually mercury. It took approximately 5 days before the PKDs and other agencies were notified by the school authorities. Okay. With regards to the second question, any updates of those students after 4 years of the event? So students were generally the largest group that were exposed, and the PKDs did inform the students and the families and also the agencies involved about the symptoms of acute mercury toxicity. However, since the laboratory investigations came back as insignificant, the chelation therapy was not performed. Therefore, we did not follow up the students after the incident.
Okay, thank you, Dr. Suping. So actually, just received one more question for Mercury Group. So the number third question for Dr. Suping: what are the effects of mercury toxicity to children or the infants? Can you help to answer? Thank you.
Okay, thank you. So, mercury toxicity to children or infants, it's very bad because infants and young children who've been exposed to high levels of mercury may have delays in terms of cognition, fine motor skills, speech and language development, and visual spatial awareness. As we know that mercury is a neurotoxin, but besides that, it can also damage brain, kidneys, and most of all, the developing fetus. Okay.
Okay. Okay, thank you very much, Dr. Suping. Okay, there's a question from Dr. Samsul Bahari. There's 3 questions there. Number 1, which is most toxic, organic or inorganic heavy metals? Number 2, did the Public Health Malaysia have their own guidelines for heavy metals exposure? And number 3, based on current study in 2020 to future, heavy metals exposure is most risk in environmental or occupational exposure. It seems like there's no specific group to answer it. So why not we make it fair? The first question, which is most toxic organic or inorganic heavy metals, will be answered by group number 1, which is the lead group. The question number 2, did the Public Health Malaysia have their own guidelines for heavy metals exposure, will be answered by the Cadmium group. And the final question, based on current study in 2020 to future, heavy metals exposure is most risk in environmental or occupational exposure, will be answered by Arsenic group. The first group is Dr. Arif.
Okay, thank you, Dr. Ihsan. So, which is most toxic, organic or inorganic? So for lead, especially, yes, there was organic and inorganic lead. Okay, so I found out many studies for lead. They found out organic lead is less toxic compared to inorganic lead. This is because they can undergo degradation faster compared to inorganic. Okay, but then I believe this is related to other factors also, such as age, type of heavy metal, and is also debatable. I found out some researchers said also that organic and inorganic, they have same kind of toxicity. So that's my answer for that question. Thank you.
Okay, group number 2, group Cadmium, to follow up for the second question.
Kalau yang di Utara Selatan ni tak ada.
Okay, thank you for the question. Okay, regarding the law and regulation, in Malaysia actually we have the law and regulation for heavy metal exposure, but only focus on the occupational settings such as our Factory Machine Act for the lead exposures. However, for general population, we still depends on other established countries such as the United States Environmental Protection Agency, and also the Agency for Toxic Substance and Disease Registry, which is well known as ATSDR. So yeah, we still refer to others in terms of the public health guideline. Thank you.
Okay, group number 2, thank you very much. Arsenic group, please follow on the third question.
Sorry. Okay, I will try to answer the question for which is more hazardous, environmental or occupational exposure. In this short period of time, we are unable to find the studies in 2020 or the future. Therefore, the latest findings that I found was in 2019 by Ali et al., which mentioned that the environmental exposure is the most at risk because we are unable to anticipate the level and also the exposure and also the event of the eruption or any exposure to the toxic. However, in occupational exposure, we are able to anticipate the risk according to the level of exposure, and that has predetermined. Therefore, we can implement the appropriate measures to reduce the exposure, such as the elimination, substitution, engineering, administrative approach, and also the PPE. Therefore, in my opinion, the heavy metal exposure in the environmental is most risky lah. Okay, But however, both exposure is also high in risk of causing toxicity lah. If the measure is not prevention and also safety measures are not taken care. Okay, I think that's all.
Okay, thank you very much to Dr. Intan, representative for Arsenic Group. Okay, I know we have run out of time, but we have one last question for the lead group. Let me read it up. Dr. Arif, maybe you can get ready. So question to group one, beginning in 1976 in the USA, children as young as 6 years old are required to undergo the blood lead screening. At what age for children in Malaysia? So this question was asked by Dr. Zamzuri. So please, Dr. Arif.
So if, as I understood the question, at what age for children in Malaysia? So for now, we don't have such a policy to screening any for lead screening in any age of children. So if you want my suggestion regarding age for children in Malaysia, so of course I don't have much information to give suggestion, but as a developing country, we should review why such country as US developed country do at 6 years old, and is it applicable to our country to follow such a regulation. So basically I don't have any answer to suggest for at what age children in Malaysia should do.
Hello, Dr. Arif. Okay, okay, thank you very much to Dr. Arif for the last answer just now. Ladies and gentlemen, we have reached to our time. So we have finally come to an end of our webinar session. We would like to say thanks to the presenters for the interesting presentation and also to all the audiences for your active participations. We also would like to take this opportunity to thank the Department of Community Health UKM for the approval of this webinar. Our special gratitude to Prof. Dr. Hasni for his continuous support in materializing this event. And not to forget, credit to all the JKM staff, especially to Mr. Sazman for his hard work in technical support. And my personal thanks to my co-host, Dr. Shuhada, who is here with me, and also the crew members, Colonel Dr. Zulkifli, Dr. Nazrin, Dr. Intan, and Dr. Fikri, who are also here with me to make this webinar a success. Thank you for your attention. So there's a request from the Professor Hasni to take a photo for all of us. So I hope you all can switch on your cameras, and we will take a screenshot of the photos. Ima. Okay, is everyone ready? So it seems like only few. Dr. Ima, Dr. Farid. Okay, we I think, yeah, we won't waste any more time. So let's do what we have. Okay, so 1, 2, 3.
Okay, one more.
Okay,
Page
so
two.
one more.
Page 2.
Oh, no one in page 2. Okay. 1, 2,
2,
3. Okay.
Page 3.
Oh, there's 3 pages. So the third page, maybe 1, 2, 3. Okay. So the page 1, 2. Let's do a freestyle. Okay.
It's me.
Okay. Please freestyle.
1, 2,
2,
3.
1, 2, 3. Okay, thank you very much. With that, we have come to the end of our webinar. Thank you very much again for your attention. Assalamualaikum warahmatullahi wabarakatuh and have a good day. Thank you.